Let's look at the diagram. OAD is a sector of a circle with radius r. OA and OD are radius r. Angle AOB is x radian. Remember the angle is in radian. AB is perpendicular to OD. CD is tangent to the circle and perpendicular to OD. OAC are on the same line. Look at triangle OAB. OA is r. So AB is r sin x. Since x is in radian, the length of arc AD is rx. Look at triangle OCD. OD is r. So CD is r tangent x. From the diagram, we know AB is less than or equal to AD, and AD is less than or equal to CD. We can cancel the r in the inequality. So we have, sin x less than or equal to x, less than or equal to tangent x. Tangent x is sin x over cosine x. Let's divide sin x and get, 1 less than or equal to x over sin x, less than or equal to 1 over cosine x. When x approaches 0, cosine x approaches 1, and 1 over cosine x approaches 1. So x over sin x is sandwiches between two 1s. Therefore, the limit of x over sin x when x approaches 0 is 1. Since the limit of x over sin x when x approaches 0 is 1, the limit of sin x over x when x approaches 0 is also 1. Remember, this result is valid only when x is in radian. X must be in radian. Let's find out the derivative of y equals sin x. X must be in radian. dy over dx is the limit of sin x plus del to x minus sin x over del to x when del to x approaches 0. We need to change the numerator. We know sin a plus b is sin a cosine b plus cosine a sin b. Sin a minus b is sin a cosine b minus cosine a sin b. Subtract these two equations. We get, sin a plus b minus sin a minus b equals 2 times cosine a sin b. Let p equal a plus b, and q equal a minus b. Then, a is half p plus q, and b is half p minus q. Therefore, sin p minus sin q is 2 cosine half p plus q sin half p minus q. We use this formula to change the numerator into 2 cosine x plus half del to x sin half del to x, over del to x. Divide 2 on both sides. The limit can be written as, cosine x plus half del to x, times sin half del to x over half del to x. Since x is in radian, the limit of sin half del to x over half del to x is 1 when del to x approaches 0. The limit of cosine x plus half del to x is cosine x. Therefore, the derivative of sin x is cosine x. Again, x must be in radian. In calculus, all angles are in radian. The derivative of sin x is cosine x. With the same approach, we can find the derivative of cosine x is minus sin x. We'll not show the derivation here. Pay attention to the minus sign in the derivative of cosine x. Let's look at some examples. The derivative of sin 2x is cosine 2x times the derivative of 2x. The result is 2 cosine 2x. The derivative of cosine 3x is minus sin 3x times the derivative of 3x. The result is minus 3 sin 3x. The derivative of 5 sin 3x squared is 5 cosine 3x squared times the derivative of 3x squared. The result is 30x cosine 3x squared. We can also use product and quotient rule. The derivative of 2x sin 3x squared is the derivative of 2x times sin 3x squared, plus 2x times the derivative of sin 3x squared. The derivative of 2x is 2. The derivative of sin 3x squared is cosine 3x squared times the derivative of 3x squared. So the result is 2 sin 3x squared plus 12x squared cosine 3x squared. The derivative of 2 sine 3x over 4x squared plus 1. The denominator is the square of 4x squared plus 1. The numerator is the derivative of 2 sine 3x times 4x squared plus 1 minus 2 sine 3x times the derivative of 4x squared plus 1. The result is 6 cosine 3x times 4x squared plus 1 minus 16x sine 3x over 4x squared plus 1 squared. Now let's find the derivative of tangent x. Tangent x is sine x over cosine x. We can use quotient rule. The denominator is cosine squared x. The numerator is sine x dash cosine x minus sine x cosine x dash. Sine x dash is cosine x. Cosine x dash is minus sine x. So the numerator is cosine squared x plus sine squared x, which is 1. 1 over cosine squared x is secant squared x. So the derivative of tangent x is secant squared x. Now let's find the derivative of inverse tangent x. When y is inverse tangent x, x is tangent y. dy over dx times dx over dy is 1. X is tangent y. So dx over dy is secant squared y, which is 1 plus tan squared y. It is 1 plus x squared. Therefore, the derivative of inverse tangent x is 1 over x squared plus 1. Let's look at some examples. The derivative of tan 3x squared is secant squared 3x squared times the derivative of 3x squared. The result is 6x secant squared 3x squared. The derivative of inverse tan 5x is 1 over 5x squared plus 1 times the derivative of 5x. The result is 5 over 25x squared plus 1. The derivative of inverse tan x over a is 1 over x over a squared plus 1 times the derivative of x over a. The result is a over x squared plus a squared. In this class, we learned the derivative of sine x is cosine x. The derivative of cosine x is minus sine x. The derivative of tangent x is sec squared x. The derivative of inverse tangent x is 1 over x squared plus 1. All angles must be in radian.